So my name is Michael Jenkinson, Managing Director of Booth Industries over in Bolton. We're manufacturing the HS2 door sets, of which there are 300 of. Booth Industries has been around for over 150 years. We employ just short of 150 people. This factory has been custom made for the HS2 production line, where we'll be making the 300 door sets over the next 5 years, and then we'll be installing them. They're around approximately 600 kilograms per leaf. The doors have got to withstand 2 hours of fire integrity, so that means that the fire cannot breach that within that 2-hour period. There's 60 minutes of fire insulation, which means the non-fire side of the door set has to stay cooler than a certain temperature for it to pass it. They've also got cyclic loading on them around 7 kPa, which is approximately a 300-mile-an-hour wind load, which has to be withstood over 7 million cycles in a 30-year design life. Another really interesting fact about the doors is that these doors have to be installed in a 4-hour engineering window. So when the trains are actually in operation, the railway's in full operation, if ever we have to go in to maintain these, we can strip out a door and put a new one in within a 4-hour period. We've never done that before. That's a 600 kilogram door actually delivered and installed and then back in operation within that engineering period. So we started investigating modern methods of manufacture a number of years ago, knowing that there's around 300 of these door sets, all of which are going to be similar, if not identical in nature. So we were looking for repeatability and to make sure that the assurance that we provide with the door sets means that every one of these doors performs in exactly the same way in the event of an emergency. The robot provides the best consistency and the most efficient way of manufacturing. In fact, it's been able to cut down welding times of around 12 hours to as little as 25 minutes. So the Chiltern door test installation that we carried out a couple of weeks ago was the first of type. We were actually looking at some of the new installation equipment that we purchased for the project, and actually how that would behave in the tunnel environment itself. So we took the first door down there. We had a number of the supervisors down there, the installation teams, our SHEC team, and members of the HS2 team as well to witness this. This was a key operation because effectively it means that we'll be videoing how that's going to actually be installed in the future when the project materialises to that stage. The installation all went well, so we actually took the door sets down. Within that 4-hour window, we were able to move it into position. The lifts were carried out safely. Everyone was pleased with the way it had gone. So this is one of the HS2 cross-passage door sets that have been manufactured in our facility. It's in a fat rig currently, so each one of the door sets is going to be manufactured, put into the fat rig to test that it's going to function exactly as we'd expect in real life.
Here at the HS2 Chiltern Tunnel to undertake a trial installation of our first cross-passage door. This is a key milestone for the project because it's the first railway systems asset of this nature being installed within the civils infrastructure. So a cross-passage door essentially is a safety critical asset. It's designed and used to fundamentally provide a safe access for passengers and emergency services in the unlikely event of an incident within the tunnels. In such a situation, passengers would escape via the designated escape route through the cross passageways into the adjoining tunnel up to the safety muster point. So they're installed using a bespoke lifting crane. This is a spider crane within the tunnel connected to a vacuum lifting mechanism. And that approach allows the doors to be manoeuvred into place with minimal effort and without harm for individuals. So the trial installation is really important to us. It allows us to trial the installation within the confined space of the tunnel environment before we scale up. It allows us to refine the process, really understand where we can have efficiencies in the installation, reduce risk, such that when we install hundreds of these doors in the HS2 tunnels, that we do so in the safest and most efficient way possible. What we're really doing here is testing repeatable installation. By making fine adjustments from the trial, we'll be able to refine this process going forward, such that any small benefits that we can encounter through this trial would translate to significant time, cost, and savings in the future, noting that we'll be installing hundreds of these doors. For example, the door, despite weighing over 650 kilograms, has been engineered such that it can easily be operatable. Now, I'll just give you a demonstration. So within the door there is a counterweight assembly which needs to be fine-tuned. That allows us to be able to freely open and close these doors with minimal effort. Thank you.